The structure of ascorbic acid or vitamin C is shown below. How many pi bonds and how many lone pairs of electrons does vitamin C contain? So first we will consider pi bonds. So we have two types of covalent bonds that we will see in our organic molecules. We will see sigma bonds and we will see pi bonds. So our sigma bonds are that first point of connection between two atoms in an organic structure. So all single bonds are sigma bonds. And then whenever you have a multiple bond, so if you have single bonds, they're all sigma bonds. If you have a multiple bond, that first point of connection is a sigma bond. So whenever you have a multiple bond, you have one sigma bond, and the remaining bonds are pi bonds. So we say we have one sigma bond, and the rest are pi bonds. So all we are considering here if we're looking for pi bonds is we're looking for where we have multiple bonds. And we see that we have two double bonds in this molecule. So for each of these double bonds, we would say one of the bonds is a sigma bond and one is a pi bond. So we have 1, 2 pi bonds in this molecule. Okay, so that answers the first part of our question. The next thing we're being asked is about the lone pairs of electrons. And so we have carbon, hydrogen, and oxygen as our elements in this structure. So a neutral hydrogen, and we know that everything is neutral because we don't have any charges displayed. So a neutral hydrogen will be a hydrogen that's forming just one bond. A neutral carbon atom is a carbon atom that is forming 4 bonds, and it might be 4 single bonds, or it might be some combination of single and multiple bonds, but adding up to a total of 4 covalent bonds. And we don't have any charges on any of these carbons, so we know that they are all forming 4 bonds. There are no lone pairs of electrons on neutral carbon atoms, so we don't need to consider those. We do need to take a look at the oxygen, and we know, hopefully, that a neutral oxygen atom will have 2 bonds and 2 lone pairs. And the bonds could be 2 single bonds, as we've shown here, or you could have a double bond, as in this one. So all we need to do is we need to put the lone pairs on all of these oxygens. So every single one of these oxygens will have 2 lone pairs. So we can draw them in. And we could count those pairs, or we could recognize, well, we've got 2 lone pairs for every oxygen, and if we count that we have 6 oxygens, then we would know that 6 times 2 is 12, and we have 12 lone pairs of electrons. And so that means that the correct answer here is B.